Okay, for this recording, we're going to be just burning through numbers 7 through 14 rather quickly. Again, when we're adding or subtracting these, we just need to make sure we have like terms. We need to have the same radical. When we are multiplying, we multiply the coefficients together, and we multiply what's inside the radical together. And then we reduce if possible. Always reduce if possible. So, for number 7, without further ado, we are adding, so we need like terms. 28 and 45 are not the same, so we're going to go ahead and reduce real quick. So this is 5 times the square root of 4 times 7. 4 is perfect square, so I'm going to divide that out. 2 on the square root of 9 times 5. So if I pull the 4 out, the square root of 4 is 2. 2 times 5 is 10, so 10 on the square root of 7. Plus, square root of 9 is 3, so 3 times 2 is 6 on the square root of 5. Now, this is one of those rare cases where no, that is your answer. That is simply as reduced as this gets. They do not add or subtract together. I was really just trying to see if you were paying attention and could remember your rules. Number 8, same idea. We'll start off by reducing this. 75 is not divisible by 64, 49, 36, 25. 25 is the largest perfect square that goes into 75, so negative 4, square root of 25 times 3, plus 3 times, well, in this case, 36 is a perfect square, so I'm just going to go ahead and take the square root of it and get 6. So, the square root of 25 is 5, so 5 times the negative 4 out front is negative 20, and the 3 is left over. Plus 3 times 6 is 18. And again, we have different terms. So there you go. Number 9. Okay, we're not adding or subtracting on number 9. We're multiplying. So we simply just multiply what's inside the radical. And again, when you're multiplying a fraction, you just multiply straight across. Top with the top, bottom with the bottom. So in this case, we get 3 times 7, which is 21. 8 times 2, which is 16. And we reduce. The square root of 21, well, there's no perfect square that goes into 21. But 16 can be 16 is a perfect square. It's 4 times 4. Right? And if we could divide a perfect square out of 21, we would, but we can't, so we leave it alone. Right? Number 10. Start off by checking your operator. In this case, we are subtracting. So again, we need a common denominator. 150, again, is divisible by 25. So that is 25 times 6. And remember, I'm not dividing by any radical. I'm dividing by perfect squares. 96 is 16 times 6. So square root of 25 is 5, so 5 on the square root of 6. Square root of 16 is 4. Multiply that by the 5 out front, so that's negative 20 on the square root of 6. All right, now this time I do have the same radical, so I'm going to go ahead and combine those together. So 5 minus 20 is negative 15, so let's erase that. Negative 15 on the square root of 6 is your answer. All right. Number 11 and number 12 are the same way. If you want to pause and try those right quick, I would suggest you go ahead and do it, but I'll do number 9 right quick. Number 9, there's nothing to reduce on this. 13 and 11 are all prime, so we can just combine terms. But these are the same, so we're going to combine those. 9 plus 1 is 10, so in this case it's 10 on the square root of 13. And the 6 times the square root of 11 just drags along behind. Hangs out for the party, and that's it. Number 12, same idea. But again, we're going to start off by reducing as far as possible. Come on. Okay. There we go. 2 is as far down as that goes, so it's 4 on the square root of 2. 72 is divisible by 36, so that's 6 on the square root of 36 times 2. Negative 32 is 16 times 2. Okay, and we can reduce those. Still got negative 4 in the square root of 2. 6. 36 is 6 times the 6 out front, which becomes 36 again. That one confuses the mess out of people, but remember the 36, we took the square root of it, so it became a 6. Multiply it by the 6 out front, and that went back to being a 36. And last but not least, square root of 16 is 4. 4 times the 8 out front, so it's negative 32 on the square root of 2. Alright. Why I wrote a 3 right here, I have no idea. The 2 dragged along. We'll go from there. Okay, if you were wondering about that, I don't know, brain fart. Again, we have the same radical for all these, so we are going to add the coefficients. In this case, I'm going to do negative 4 plus 36, that's negative 32, plus positive 32, I'm sorry. Minus 32 is 0, so that is 0 square roots of 2, which is the same as saying just straight up 0. All right. All right, last but not least, 13 and 14. Again, for 13, we're multiplying, so we don't need the same thing on the inside and the outside. And again, we're multiplying fractions, so I'm just going to multiply straight across the top, straight across the bottom. 25 times 6 is 150. 2 times 18 is 36. All right, and I'll just reduce those. The square root of 36 is 6. Square root of 150, well, that's 25 times 6, which the square root of 25 is 5. So it's 5 on the square root of 6 divided by 6. Right. And last but not least, number 14. If you haven't tried it yet, just go ahead and do it. But 112 is 16 times 7, actually. So let's do this. 4 on the square root of 16 times 7 plus 5 on the square root of 56 divided by, give me a second, 56 is 4 times 14. I had to think about that one for a little bit. And then last but not least, perfect square that goes into 126 is 9. It's 9 times 14. All right. So here we go. The square root of 16 is 4 times the 4 out front, turns it back into a 16, so that's 16 on the square root of 7. Square root of 4 is 2 times the 5 out of front, that's 10 on the square root of 14. Square root of 9 is 3 times the 9 out front is 27, so that's negative 27 on the square root of 14. And hopefully you've already realized that you can't connect the first one, but you can connect the second two because they have the same radical. Alright, so we have, for our final answer, just bring down 16 on the square root of 7. 10 minus 27 is negative 17, so that's negative 17 on the square root of 14. And that's your final answer.